There's a World Health Organization report from 2016 which has all the data, and it says, okay, that cities in Pakistan are pretty bad. Peshawar is the worst, and I was quite surprised that I think these 5 cities are in the top 12 worst in the world as per World Health Organization data. But I was like, how can Peshawar be worse than Karachi or Lahore? And then I went a little bit into the details of the data, and I found out that the data dates back to 2008 and 2011. It covers 1 or 2 weeks of monitoring, and during those 1 or 2 weeks it covers in certain cities like 1 or 2 hours of monitoring in a day. So it's not really representative of anything. And to give you a comparison, Delhi and Beijing, so Beijing for a long time, you read about it all the time that it's got the worst air in the world. A few years ago, well actually last year, the conversation turned and now people say Delhi has the worst air in the world. And you can see from the data how that compares to Pakistani cities, like Delhi is 122, Lahore is 68 as per World Health Organization data. What a good city looks like, numbers look like Paris and London at the bottom are between 15 and 18. Here we're talking about PM 2.5 concentration. So let me explain what that is, because that's a very important factor to understand before we go further. Okay, that's for the thing. So can you see that human hair on the screen? Let's zoom into that a little bit. That's the human hair enlarged. And then let's see fine particulate matter. So PM means particulate matter. We say 2.5, that's the size or the weight of the particle in micrograms. So that's how small it is in comparison to a human hair. There's also PM10, which is a much bigger particle, so 4 times bigger than that, but that is also much, much smaller than human hair. So some people think, oh, it's dust in the air, I have nothing to worry about. Well, that's true. If it is dust, you don't have anything to worry about because it's much bigger. Dust particles start at PM10 and upwards. An average dust size would be like closer to 100 micrograms, like closer to the size of a human hair than these things. So next is that's the size of PM2.5. Dust that we're talking about. We're talking about metals, we're talking about, well, mostly metals, which are the byproduct of biomass burning, which is trash burning. So you don't have to read the slides. That is designed to confuse you. You're seeing a lot of chemicals and so on in there. There's biomass burning, meaning all the trash that we burn. There's coal burning from the coal power plants. There is also, similar to coal emissions, you have emissions from crop burning, which are not mentioned here because we don't have the data from it. There's industrial emissions, vehicular emissions. So this is all what's contributing to what we say is PM 2.5, or rather the contents of PM 2.5 itself. Some people also ask, what about the gases? Like, why are we looking only at PM 2.5? Why don't we look at carbon monoxide or nitrogen dioxide and so on? Those gases actually form complex compounds together with these. So as you can see, I've mentioned sulfates, nitrates, ammonium, secondary organic, what is it called, aerosols. So those gases are also a component of the PM 2.5, except they're coming together with these particles as an aerosol. So essentially, the most effective indicator of air quality in terms of human health is PM 2.5. So you have PM10, the bigger particles which are also measured. You have the gases which are also measured. But this is the critical particle that one should be. What happens to these particles? So yeah, like I said, they're trace metals and gases, aerosols, and so on. You breathe these in. PM10 usually is blocked out by your respiratory system. It sticks to the mucosa and it doesn't really go further into your body. it's not that it's not a problem, but it's not as severe an issue. It does cause respiratory issues, like it can cause asthma, it can cause lung issues, and so forth. But it's the fine particles, the PM2.5, which enters inside your body, and once it's inside your body, it gets your lungs, from beyond the lungs. These particles are really, really small, so it absorbs into your bloodstream, and from there, it can, cause damage to your lungs, it can cause cancer. Cardiovascular issues are very commonly correlated with this. It's something you want to stay away from. In Pakistan, the PM2.5 levels are 4 to 12 times higher, in Lahore. Then the World Health Organization recommended limits to exposure to PM2.5. During the 5th season of that smog crisis that we had in October, November, it went up to 100 times that amount. Just before I tell you about the good days, it's also a question of how we measure good. So we equate, or rather here I'm talking about the United States EPA data index. Other countries have a different index. So India has something different, European Union has something very different, China has something different, but generally they all look similar to what the United States has done over here, where you divide it into these 6 sections from good to hazardous. The index includes not just PM2.5, it usually also includes the other elements, but it depends on which element is making it bad or hazardous, which has then the effect. So if you have no problem with carbon dioxide, for example, then it won't affect the index. So PM2.5 is usually the one that affects it most. So good, they say when the concentration is below 12, then that's a good level that you're at. Lahore had 2 good days in 2017. Very unhealthy and hazardous days. Those are days where you don't want to go outside, you don't want to send your kids to school, you want to avoid any outdoor activities, you should put on a face mask, and so on. So none of our cities are good, but Lahore is exceptionally worse, which I was surprised to find out about myself, because I always thought Karachi would be much worse for air with more industry, December, and you can see also January. That's an excellent question. What crop is burning in January? I don't know. What I want to tell you is that it gets hazardous in these months, but it's not looking so great the rest of the year either. And I'll go back into what's causing it, what's causing the air pollution. But it's much easier to measure gas than it is to measure PM2.5. So I can imagine that the data quality there is much better. So here's what we see. So this is now the average values since November to yesterday that the EPD has put out there. We can see that ozone is not a problem. Neither is sulfur dioxide. Carbon monoxide is nearly twice the safe limits. This is in reference to the safe limits just defined by the Pakistan government. Nitrogen oxides are 3 times higher of the nitrogen dioxide variety, and the nitrogen oxide variety is 5 times higher than the safe limits. Well, this is from 12 p.m. today, so this afternoon. So it's very complex how air pollution is generated. So on the south you can see Karachi. There's a bit of a hot spot over there, but with a nice sea breeze, most of the air pollution is blown away. Lahore, you can see the dark red spot over there. So right now Lahore looks worse than New Delhi. So one thing is about the sources of air pollution. The other thing is about wind conditions. So where's the wind coming from? So it can be blowing pollution from a different part of the country or from another country also into where we are. Then the third thing, which is very important for Punjab, is this temperature inversion that's happening in the winter months. where the cold air is being trapped inside with hot air on top. Usually it's the opposite. So everything that's being generated in terms of pollution from Lahore and in Punjab stays here. It's not going anywhere. Or rather, if the temperature inversion wasn't happening, it would just disperse much quicker, and that's why I don't have this issue. So like what we're seeing in January and December, like during the smog season, you're generating the same pollution year round. You just don't see it. No, that's weather conditions that's creating the ceiling, which is then keeping the pollution trapped inside. There's one paper from, the paper was published in 2010, but their data is from 2005 and 2006. And I also saw some other papers from the, I think they get the data from the government gives them all the data, so you can't really rely on it. Secondary emissions, not sure what that refers to, but diesel, biomass burning, coal combustion, two-stroke vehicles such as your rickshaws and motorcycles. So proportionally to how few they are, they're a big contributor, and industry is a minor contributor, as you can see from this. But of course, industry is also combusting coal and so on. There exist some estimates that brick kilns contribute about 30% of these emissions. So that would be, of course, also what's contained here for coal combustions. Then in the winter months, you have a crop burning. So we don't know where it's coming from, really. So we kind of have this data from 2005, 2006, but where is it coming from last year or this year? That is a field of area where more work needs to be done. Because until you know where it's coming from, you can't go out there and address it. Like, you can say, oh, let's shut down all the industry, but maybe that's not the area where you need to focus on. So from what I found out, the two main areas are brick kilns, which are operating year-round, and the second one is crop burning as a priority, which needs to be, where you need to give an alternative to those industries or to the farmers. What can you do is the question. Not too much right now.